Hello, this is Mr. Stansbury. I'm going to take you through the notes on trigonometric ratios, also known as trig ratios. At the end of this, you should be able to say, I understand the definitions of sine, cosine, and tangent ratios, and I can calculate the trigonometric ratios in a right triangle. Okay, so first we need to know what trigonometric ratios are, or trig ratios. Trig ratios describe the ratios of one side to another in a right triangle. Okay, so there's three different main trig ratios that we like to use. Sine compares the length of the opposite side over the hypotenuse. Cosine is the adjacent over hypotenuse. Tangent is the opposite over adjacent. Okay, and then what we're talking about with opposite and adjacent and all that kind of good stuff is if we have a triangle that looks like this. Okay, so with this triangle here, let's say, so this thing here is called theta, and that's a variable for an angle that we don't know. So it's always from this angle. So from this angle, there's three different possible sides of the triangle. There's an opposite side, an adjacent side, and a hypotenuse. Okay. One that you usually want to start with figuring out first is the hypotenuse, because that will always be the same. So from this, hypotenuse is always the longest side and across from the right angle. So this is the hypotenuse, right? And then we are left with adjacent and opposite. So from this, adjacent means right next to. So right next to is this side and this side. Since this is the hypotenuse, that's why I like to put the hypotenuse on first. Since we already know that's the hypotenuse, the only other one that's right next to it is this one here. So this one we call the adjacent. And then opposite means across from. So across from this angle here is the opposite side. Okay, so that's what these opposite, hypotenuse, and adjacent are meaning here. Okay, we often will see this, instead of written out with all the words like this, we'll see it shortened to sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So this is, again, still pronounced, even though it says it's spelled S-I-N, like sin, you still call it sine. You don't call this cos or cos. Well, we can call it cos for cosine. And this is tan or tangent. Okay? A easy way to remember all these three main trig ratios is a little mnemonic device, and it's Sohcahtoa. So if you can just say Sohcahtoa, and I like to write it out like this. So, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so that's Sohcahtoa. And that's, like, the quicker you can remember that, the easier all this trigonometric ratio stuff will make more sense and be easier for you. Okay, so let's do this. Let's find the following trig ratios of this here. So first thing, before you want to start filling any of this, you got to figure out which of the sides we have. Again, opposite, adjacent, and hypotenuse are the three we're looking for. Across from the right angle, we know that this is the hypotenuse. Here's the angle that we're looking for. Like, this is our reference angle, we call that. Opposite of that reference angle is this side here, so that's O for opposite. And adjacent are these two sides, but since this is the hypotenuse, this means that this has to be the adjacent side. Okay? So now that we have these all labeled, now we can fill out our trig ratio. So sine of theta, sine, if you remember, is opposite over hypotenuse, O over H. So from this angle, the opposite side is 12. So we'll just put 12 over hypotenuse is 13. And that's our trig ratio for the sine of theta. Okay. Cosine is adjacent over hypotenuse, 5 over 13. Right? Adjacent over hypotenuse. Tangent is opposite over adjacent. So this one here, opposite is 12, adjacent is 5. So that would be 12 over 5. Okay? So those are our trig ratios. Okay, let's take a look at one more set here. Oops. Let's get rid of that. Okay, we're going to look at one more set of examples here, but first let's take a little comedy break. Okay. Sorry, that one kills me every time. That one's funny. Find the following trig ratio. So here's our triangle. And now what it says find the sine of A. So that means we want to find the sine where angle A is our reference angle. So really our theta is right here. Okay. So from this angle, this here is across from the right angle is always the hypotenuse, right? From this angle, opposite of this angle is the 8, so that's the opposite. And then from this angle, these two sides are adjacent. This is already the hypotenuse, so that means that this here has to be the adjacent. So now we can fill in all of our ratios, okay? So I'm gonna try to start using this one right here because it makes it it'll make our lives a little bit easier. So sine is opposite over hypotenuse. So opposite is 8, hypotenuse is 6. Sorry, hypotenuse is 10. 8 over 10. Now, this can be simplified, so let's turn that 8 into 10 into 4 out of 5. Okay? Cosine is adjacent over hypotenuse, so that's adjacent is 6, hypotenuse is 10, so that's 6 over 10, which reduces down to 3 over 5. Okay? And then TOA, the tangent is the opposite over adjacent. So that's going to be 8 over 6. Both those are divisible by 2, so that's 4 thirds. And those would all be our trig ratios. Okay. Now, here's something interesting that's happening here. Now we're going to do sine of B. Okay, so now here's angle B. So now our reference angle is here instead of over here. So the good news is the hypotenuse will always be the hypotenuse, but now from angle B, the opposite side now is 6. And the adjacent side now is 8. Okay, so depending on what angle you're coming from is going to change your adjacent and your opposite side. Your hypotenuse will always be the long side across from the right angle, but it depends on which angle you're looking at as which is opposite and which is adjacent. Okay, so now if we look here at sine of B, sine is opposite over hypotenuse. So we're looking at the red now. Let's leave that as an H here. So opposite over hypotenuse, that's 6 over 10. 6 over 10, which reduces down to 3 over 5. Okay, and then cosine is adjacent over hypotenuse. That's 8 over 10, which is 4/5. And then tangent is opposite over adjacent. So opposite is the red, opposite 6 over 8. 6 over 8, which is reduces down to 3/4. Okay. Now, if you'll notice, sine of A and cosine of B are the same, 4/5, 4/5. And cosine of A and sine of B are also the same, 3/5, 3/5. Okay, that's not a coincidence. That will happen every time if you switch the two angles. Then these two will get switched around. Okay, and if you'll notice also, tangent of A is tangent of B is just the reciprocal of that. So it got flipped over, right? So the 4 went to the bottom and the 3 went to the top, just like that. Okay. All right. That's all we have for trig ratios. If you have any further questions, please feel free to ask in class. Thanks.